Hello guys, good morning. You are welcome to my YouTube channel, The Explicit Tutorials. As you all know, my name is Lord Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be looking at the part 2 of the state of matter in chemistry. We've treated the part 1 already. If you know you have not watched it, I will advise you do so. Please, it is very, very important. Now, the part 2 of this topic is centered on ideal gas laws. Ideal gas laws. Ideal gas laws. And we are going to be looking at the three laws that make up ideal gas equation, all right? One of these laws of Boyle's law. Boyle's law. Now, Boyle's law shows the relationship between volume. Boyle's law shows the relationship between volume and pressure. Yes, it is not pressure, it is pressure. Boyle's law shows the relationship between volume and what? Pressure. Take note of that. Now, what is Boyle's law? Boyle's law states that the volume of a given mass of a gas is inversely proportional to its what? Pressure, provided that the temperature is kept constant. So which means that in Boyle's law, it is the temperature is what? Kept constant. So from here, if I were to eliminate the proportionality sign, I will have to introduce constant K, right? So that becomes V equals K over what? P. If I should cross multiply based on what I have right now, I'll be having K is equals PV. Therefore, this becomes P1 V1 equals P2 V2. So this is what? Boyle's law. PS stands for initial pressure, V stands for initial volume, P2 stands for final temperature, final pressure or standard pressure, and V2 stands for what? Final volume. So please take note that standard temperature is what? 273 Kelvin, while standard pressure is 760 millimeter mercury. Please take note of that. Standard temperature is 273 Kelvin, while standard pressure is what? 760 millimeter mercury. Take note of that. So that is all about Boyle's law. Now, if I may ask, if V is inversely proportional to P, what does that tell you? It means that as V increases, P will what? Decrease. As volume increases, the pressure decreases. As pressure increases, the volume decreases. Inverse relationship, all right? So please take note of these graphs. When volume is plotted against pressure in this form, what do you have? You have a curved graph. But when volume is plotted against temperature, when volume is plotted against pressure as 1 over P, all right, you have a straight graph, all right? Or you can also have that PV, and this is also what? Straight. So which means if V is plotted against 1 over P, that is V against 1 over P, or P against 1 over V. So please, you'll be having something like this. But when volume is plotted directly against pressure as this, you have what? A curved graph. So please Take note of that. Now, the next one is what? Boyle's law. The next one is Charles' law. Boyle's law, I said, shows the relationship between volume and what? Pressure. Take note of that. The next one is Charles' law. We have JAC Charles. JAC Charles. J stands for Jacques Alexander. Jacques Alexander Caesar Charles. So this is the full name of Charles. Jacques Alexander Caesar Charles. But in secondary school, they will tell you Charles. They will not tell you the full name, alright? So it's good you know the full name of this guy. His experiment was conducted in year 1787. Alright, please take note of that. So Charles' law shows the relationship between volume and temperature. Charles' law shows the relationship between volume and temperature, but Boyle's law shows the relationship between volume and what? Pressure. Take note of that. Now, Charles' law states that the volume of a given mass of a gas, Charles' law states that the volume of a given mass of a gas is what? Directly proportional to its what? Temperature in Kelvin, provided that the pressure is kept constant. Is kept constant. So which means that in Boyle's law, the temperature is kept constant, but in Charles' law, the pressure is kept constant. Now, if I should eliminate this proportionality sign, I'll be having V equals what? KT. Dividing both sides by T, I'll be having K is equals T is equals V over what? T. What does that tell you? It means that V1 over T1 equals V2 over what? T2. I told us V1 means initial volume, initial temperature, final volume, standard temperature, or final temperature. Please take note of that. Now, if volume is directly proportional to the temperature in Kelvin, it means that as volume increases, the temperature also increases. As temperature increases, the volume also increases. That is how it is. Now, this is the second law. The third law is Avogadro's law. Avogadro's law. I'll rub off the board now. So in Avogadro's law, the volume is directly proportional to number of moles, provided that the temperature and pressure are kept constant. Number 3 is what? Avogadro's law. In Avogadro's law, the volume is what? Directly proportional. The volume is directly proportional to what? N, provided that the pressure and temperature are kept constant. So these are the 3 laws that make up the ideal gas equation. Now, ideal gas equation is expressed as PV equals nRT. The question is, how did they deduce this formula? It is very simple. I think Boyle's law is V1 over P. It means that if V is here, P is here, it means that T and N are constant. Isn't that correct? Good. So if I have that, if Charles is T, it means that P and N are constant. Isn't that correct? Very, very correct. So if I have that V has relation that is V proportional to N, all right, it means that T and P are constant. So we have 1, 2, 3 being the laws that make up ideal gas equation. So in doing this, how are you going to do it in order for you to arrive at this point? V is common, isn't it? So it means that V is equal, the first one here is what? 1 over what? P. And of course, I have my arrow as constant, which is what? Rates. Arrow has a constant at 0.0821 liter atmosphere per degree per mole. All right. So now we have this formula already. We are going to be picking two constants from what we have here. We have constant T, we have constant P, and we have constant what? N. These three, you have a constant T, constant P, and constant what? N. From what I have here, it means I'm going to be picking constant T and what? N. So I'll put Tn here, right? If I have this, if I should cross multiply this over 1, so it means that this times this is what? PV equals, right? This times this is PV. Then this times what I have here becomes what? nRT. So what I have here is called ideal gas equation. You see now, so please, this is the formula. P stands for volume, N stands for number of moles, R stands for rate, and T stands for temperature. Now that we've established that, let me make each the subject of the formula. I have that PV equals nRT. If I want to make P the subject formula, I'll divide both sides by what? V. Which means that P is equals nRT over what? V. Equation what? 1. If I want to make V the subject formula, it means that I'll divide both sides by what? P. It therefore means that V is equals nRT over what? P. Equation 2. Right? Equation 2. Okay, from what I have here, if I want to make the number of moles the subject formula, it becomes N is equal, I'll divide both sides by RT, that becomes PV over what? RT. And this becomes your equation 3. Right? If I want to make T the subject of the formula, I'll divide both sides by what? N arrow, that is N arrow, which means I'll be having T equals N arrow over what? PV over PV equation 4. And if I want to make my arrow as the subject formula, if I want to make arrow the subject formula, I'll divide both sides by NT and what? PV. Isn't that correct? It therefore means that PV becomes what? That is PV over what? NT. Alright, so this is equation what? 5. So this is the deduction of the various formulas we have here. And you know that N represents mass over molar mass. So which means in place of this N, I can simply write it as M over, that is, if I want to express this, this becomes P equals M over, that is, M is the mass number, this is molar mass, then times RT over what? V, right? This very one is the N, so you still have what you have here. If I want to express this, becomes M over big letter N times RT over what? P. Re-expressing this, I'll have, okay, the same thing. If I want to express this, I'll have M over big letter M times arrow over what? PV. Arrow PV. Because PV is here, arrow here, and number of moles is mass by what? Molar mass. Of course, you can also express this as PV over mass over molar mass times what? T. All right, so please, that is all about the theory. That's about the laws, the ideal gas laws. Take note of it. They will ask which of the following are the laws that make up ideal gas laws. A. Charles law and Boyle's law. B. Boyle's law and Avogadro's law. C. Avogadro's law and Charles law. D. Boyle's law, Charles law, Avogadro's law. D becomes the answer because it is made up of three laws. All right, so at this point, we'll call it a day. Please endeavor to subscribe, like, share, and comment. Do have a wonderful day.